So the distance formula is a formula in math to calculate the distance between 2 points. Here we're going to look at how it's created and then an example of how to use it. First, if we look at a coordinate plane where we have 2 points plotted in the grid, we describe these points as x and y values, which is distance from the center. We have no direct connection or way of finding the distance strictly between the 2 points because of how we describe the locations of the points separately. So if we want to find the distance between the 2 points, we have to take a roundabout way and calculate the distance between the heights and the distance between the horizontal distances from 0. This will allow us to find that third distance straight between the 2 points. This may look very familiar because it ends up being a right triangle, which means Pythagorean Theorem is involved in this idea. Pythagorean Theorem, or the distance formula, is an extension of Pythagorean Theorem for the coordinate plane. Now, if we want to talk about the vertical distance, well, we have two x values. If we want to label our points quickly here, we have x2, y2. This is not writing very well. And x1, y1 as our 2 points. And as we go through to do this calculation, we would find the distance between the heights, which would be y2 minus y1, which, since it's not always guaranteed that y1 or y2 is greater, we would have them in absolute value bars if you look at any definition of the distance formula. And same thing with the horizontal distance. We would subtract the two distances. And again, it doesn't really matter which one is first. Customarily, we do x2 minus x1. As long as we take the absolute value of that, it will make sure we accurately get the distance between the 2 points. Remember, absolute value takes the positive distance of any number from 0. And that's what we want when we're talking about distance, is a positive number. Now, this will give us 2 of the sides, or the length of 2 of the sides of our triangles. So those would be A and B. So if we go ahead and plug that in, we will end up with something like this, replacing the A with x2 minus x1. Notice absolute value bars are gone because when you square it, it will automatically turn it positive anyways. And then the same thing for the b squared, just with the y values. So y2 minus y1 squared. And that's going to be equal to my third side squared, which you would now, in the formula, you may see them represented with d for distance. And then if we actually want to have distance by itself, we would simply square root both sides here. Technically, when we do this, we would have plus or minus the square root of. But because we're talking distance, and distance is always a positive relation, we would only have the positive version as a possible answer. We would have x2 minus x1 squared plus y2 minus y1 squared as our positive distance. And that's where the distance formula comes from. So if we want to find the distance between the 2 points using the distance formula, I'm going to start off by labeling x1 and y1, and then x2 and y2. And then I'm going to go ahead and plug them into that distance formula that we just looked at, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. If we go through and plug stuff in, according to how we have it set up, my x2 is 4. So 4 minus x1, which is negative 2, plus y2, which I have labeled as 5, minus my y1, which is a 3. Go through and just order of operations here. The double negative will make a positive. So we'll have the square root of 4 plus 2, which is 6 squared, plus 5 minus 3 is 2, so 2 squared. In other words, 36 plus 4, which is 40. And if I want the exact answer, I would have to simplify the radical. So the biggest perfect square that goes into 40 is 4. 4 times 10, which means as an exact answer in reduced radical form, it would be 2 square roots of 10. Or as a decimal, it would be 6.325.